Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.43 and problem 3.44 from the book Thermodynamics in Engineering Approach by CENGEL, 5th edition. So, the statement of problem 3.43 is water is boiled at 1 atm pressure and a 25 centimeter internal diameter stainless steel pan on an electric range. If it is observed that the water level in the pan drops by 10 centimeter in 45 minutes, determine the rate of heat transfer to the pan. So first, given data for problem 3-43. First I am solving 3-43. So water is boiled at atmospheric pressure 1 atm and a 25 centimeter internal diameter stainless steel fan. This is a fan and the internal dia. Internal dia mean the dia from this point to this point. This is D is equal to 25 centimeter. So dia of the fan is equal to 25 centimeter, which is equal to 25 divided by 100 meter, which is equal to 0.25 meter on electric range. If it is observed that the water level in the pan drops by 10 centimeter, it means that let's suppose this is water level, this is what, and after 45 minutes the level of the water drops by 10 centimeter. So L is equal to 10 centimeter, which is equal to 0.1 meter. 10 divided by 100. And time in which the uh, level of the water drops is 45 minutes, which is equal to 45 multiplied by 60 seconds, which is equal to 2700 seconds. Determine the rate of heat transfer to the fan. Rate of heat transfer to the find the rate of heat transfer to the fan. Required is find Q dot, rate of heat transfer. In solution, we know that at 1 atm the boiling point is 100 degrees centigrade. It is clear that at 1 atm the saturation temperature or the boiling point of the temperature is 100 degrees centigrade. Is at 1 atm saturation temperature or the boiling point of water is 100 degrees centigrade. So Ts is equal to 100 degrees centigrade, and we have to find Q dot. So the formula for Q dot is equal to, we know that rate of evaporation of water is equal to Q dot, rate of heat transfer, divided by HFG. Already explained this HFG and this formula in the previous problem. So this is equal to Q dot is equal to m dot evaporation multiplied by HFG. First we will find HFG and m dot of evaporation. So HFG, for HFG, latent heat of vaporization. HFG is basically latent heat of vaporization. So for HFG we will use formula, we will use steam table, and for rate of evaporation we will find first mass of evaporation, and from mass of evaporation time is given to us. So from mass of evaporation we can easily find rate of evaporation, and we know that as specific volume is equal to total volume divided by mass. So we can rearrange this equation as m is equal to total volume divided by specific volume, and if this is mass of evaporation, so this is, I can write this as total volume of evaporation divided by Vf, and I write Vf, this is TV diagram, this is temperature 100 degrees centigrade. So as we know that this is this is 100 degrees centigrade, temperature 100 degrees centigrade, and evaporation started at this point, mass of evaporation and our specific volume. So at this point our specific volume is Vf, and this is volume of liquid or volume of evaporation, because at this point boiling has been started or evaporation has been started. Therefore I use the term Vf for specific volume, and for total volume I use the word total volume of evaporation. So now I use steam table to find Vf and Vfg. So from saturated steam table, at temperature is equal to 100 degrees centigrade, find Vf. Vf is equal to Vf is equal to 0.001044 meter cube per kg, and Hfg is equal to 2257.03 kilojoule per kg. So for mass of evaporation, I can write this as 5 by 4 d square into L, because volume is equal to area into L, and area is equal to 5 by 4 d square, and divide by Vf. So the value of pi is 3.14 divided by 4. Diameter is 25 centimeter or 0.25 meter whole square. Length is 10 centimeter or 0.1 meter. Multiply by the value of Vf is 0.001044 meter cube per kg. So mass of evaporation is equal to, this is meter square and this is meter, so meter cube will be cancelled with meter cube, and double division kilogram will be in numerator. So simplify this value, so mass of evaporation will be equal to 4.7 kg. Now m dot of evaporation, this is simple, mass of evaporation divided by time, rate of evaporation. So mass of evaporation is 4.7 kilogram, and time is given to us 45 minutes, which is equal to 2700 seconds. So m dot of evaporation is equal to 0.00174 kilogram per second. Now rate of heat, we can easily find rate of heat transfer from the formula, from this formula, and from the Q dot is equal to mass of evaporation multiplied by Hfg. So Q dot is equal to mass multiplied by latent heat of vaporization. So 0.00174 kilogram per second, and HFG is 2257.03 2257.03 kilojoule per kilogram. So kilogram will be cancelled with kilogram, and Q dot will be equal to 3.927. This is rate of heat transfer, which are required in problem 3.43. Now we are solving problem 3.44. So there is no difference between 3.43 and 3.44, but the same problem is but at higher elevation. So at higher elevation pressure is decreases. So with the decrease of pressure, boiling point will also decreases. So here at higher elevation, repeat problem 3-43 for allocation at 2000 meter elevation, where the standard atmospheric pressure is 79.5 kilopascal. So all conditions are same in problem 3.44. Only pressure, atmospheric pressure, is 79.9 kilopascal, and remaining given data is same. Only atmospheric pressure is changed in this case. So if atmospheric pressure decreases to 79.9 kilopascal, then boiling point will also decreases. So first we are finding saturation temperature or boiling point temperature at this value. So we need from steam table saturation temperature Ts, Vf, and HFG from the knowledge of the above problem. These three values are needed from the steam table. So 79.9 kilopascal is not present in the steam table. So we will do interpolation for these three values. So from saturated steam table, at pressure is equal to 79.5 kilopascal. Find pressure in kilopascal. In the steam table, 79, 75 and 100 kilopascal are available, but 79.5 is not available. Temperature in degree centigrade. At 75 kilopascal, saturation temperature or boiling temperature is given as 71.77. And at 100 degree centigrade, sorry, this is 91.77. At 100 degree centigrade, boiling temperature is 99.62, and here this is required. Now similarly, Vf in meter cube per kg, 0.875 kilopascal, volume is 0, evaporation volume is 0.001037. Here it is required, and at 100 kilopascal this is 0.001043. And similarly, HFG, latent heat of vaporization, kilojoule per kilogram. At 75 kilopascal, this value is 2278.59. 2278.59. At 79.5 this is required, and at 100 kilopascal the value is 2258.02 kilojoule per kg. First I am doing it for TS. So interpolation, third minus first divided by third minus second. 100 minus 75 divided by 100 minus 79.5 is equal to third minus first, 91.77, divided by third value minus second value. So this is simple calculation. Do this and find saturation temperature at 79.5, which is 93.183 degrees centigrade. Now do interpolation for Vf. So third minus first between pressure and Vf. So 100 minus 75 like this, divided by 100 minus 79.5 is equal to third minus first 0.001043 minus 0.001037 divided by third minus second 0.001043 minus Vf. So simplify this and find Vf at pressure of 79.5, which is 0.001038 meter cube per kg. Now similarly do it for HFG. So third minus first 100 kilopascal minus 75 divided by 100 minus 79.5 is equal to 2258.02. Third minus first is 2278.39.59 divided by third minus second 2258.02 minus HFG, and find HFG latent heat of vaporization at a pressure of 79.5 2274. Now the remaining problem is same as, so first I find mass of evaporation like problem 3.43, so which is equal to volume of evaporation and to Vf, specific volume evaporation at evaporation, so which is equal to pi d square divided by 4L divided by Vf. So the value of pi is 3.14 divided by 4, d is 0.25 meter whole square, length is same as problems, and Vf is equal to, this is Vf 0.001038 0.001038 meter cube per kg. So this is meter cube will be cancelled with meter cube, and kilogram will be in numerator as it is in double D. So mass of evaporation is 4.726 kilogram. Now rate of mass of evaporation, m dot of evaporation, so divide it by time, and time is given to us, rate is given to us. So mass of evaporation is 4.726 kilogram, time is 45 minutes, which is equal to 2700 seconds. So mass of evaporation, rate of mass of evaporation is 0.00175 kilogram per second. Now required value is rate of heat transfer. Formula is already given in the previous problem, multiply by HFG. So rate of mass of evaporation is 0.00175 kilogram per second, and HFG is 2274.88 kilojoule per kilogram. This kilogram will be cancelled with kilogram, and kilojoule per second, joule per second is equal to watt, so this is kilowatt, and the value is 3.98. So this is the final result, and I solved problem 3.44 and 3.43 in this lecture. And please share my videos with your friends. Thank you.